See, our commitment is strong. Basically, the idea here is really to make our offering or make our services better and better. So basically catering to your needs. And we've done that through a couple of services that we've added, for example, acquiring Wild Tiger, adding asset transactions, creating MongoDB Atlas, adding support for time series collection, and also adding, basically simplifying the upgrade of MongoDB versions through the stable API. We've also made Atlas a developer data platform. So what does this mean? Well, it essentially means making your life easier by introducing services, basically, that will streamline the development of your feature. Namely, Atlas Vector Search, for example, for AI and Gen AI use cases. And MongoDB 8.0 continues this trajectory, basically. Whether you're using MongoDB Atlas or MongoDB on-prem. And we wanted today our discussion really to focus on modern application, basically. Because we are seeing more and more modern applications, basically, that they require a lot of performance, scalability, resiliency, and security, most of all. And that's basically what we will be seeing. So we have, like, our discussion today will center around four key foundational aspects. So optimal performance, so how you can gain basically better performances with MongoDB 8.0. Then we're gonna dig into workload management during increased peak usage, which means, like, even if you get, for example, unplanned events, you want to still your database, you want to still have a database that's resilient, basically, and that gives you the same capabilities. Third, which is scalability. So, of course, you want to have a solution that basically gives you the ability to scale, but scale in a cost-effective manner. And last but not least, security. So, of course, security is very important for our customers, and this is a strong commitment that we have, which means, like, making our security features better, but also offering other new features such as queryable encryption. So, before we dive into really what we did with MongoDB 8.0, I wanted to touch upon first on the MongoDB 7.0, because last year we told you that MongoDB 7.0 raised the bar in terms of performance, which is true, because what we saw, like, last year with the MongoDB 7.0 is that we basically made the complex operations better. So for grouping, for example, and reshaping, we seen 50% improvements when it comes to filtering on subfields, or on projecting on subfields. For sorting and filtering, we've noticed basically 90% increase when it comes to filtering on complex expressions, but also, like, all the $match sort project queries, they are 50% faster. And last but not least, like, $lookups in a replica set. So with the $lookups, we've noticed 4 times to 30 times better performances when it comes to version 7.0. Okay, so all these are good news. So how about the MongoDB 8.0? So MongoDB 8.0 raises the bar even higher. So in terms of performance of our MongoDB 8.0, it sets basically a new standard for performance. And when we compare it to only, like, 7.0, as you can see, for example, like with the MongoDB 8.0, you get 36% faster reads, but you get as well 56% faster bulk inserts. And for aggregations on time series, it's 200% faster. And for resharding, it's 50 times more fast, basically, it's 50 times. And when we compare just the operations per second for 7.0 to 8.0, so basically same machines what they offer, with the 7.0 you'd get around 41,000 operations per second compared to almost 56,000 operations per second with the MongoDB 8.0. And that's regardless of the workload that you're running, whether you're running AI, streams, edge, like whatever use case that you're running, you're gonna get, like, these performances because this is the core MongoDB server. And for that, we've also, like I said, no matter what the use case is. So let's dig into basically the time series part. So what is time series? We introduced first time series with the version 5.0. So time series gives you the ability to track metrics over time. for workloads such as, for example, IoT or event tracking in general. So what we did with the MongoDB 8.0 is that we introduced what we call block processing. So basically, with block processing now, what you have is that you have the ability to have faster reads, because these block processing basically relay on the columnar storage format that time series give and speed up operations that use basically $group. You know, with time series collection, you do a lot of grouping, a lot of moving average. So that's basically what we made better by giving you basically faster reads in terms of like grouping. So basically what does this mean is that you can now add complex analytical features into your application and you're gonna get like faster reads. Because how does this work essentially? So usually when you wanted basically to do, for example, moving averages or group by or something like that, you would basically go through each document. But here what we're doing is that you're processing a whole block of documents, which means from 10,000 to 20,000 documents that are processed at the same time. We've also made improvements in terms of query execution engine, starting with the command path. So basically, we've optimized the command path. And what is, maybe you are asking, what is the command path? This is what is responsible on executing queries on MongoDB. So by how we did this, we removed unnecessary steps. So usually what happened in the past is that whenever we wanted to add new feature, we would basically add this feature into the command path, but we didn't take into consideration that this may basically impact the performances. So now what we did is that we optimized the command path in its essence, so we are skipping unnecessary steps, but we also made improvements in the code that gave us basically these performances. And also, for example, with these improvements, we also were able to improve the plan cache. And thanks to the plan cache improvement and the command path optimization, we were able to reduce the scans and fetches that usually happen during those queries. So, one other thing is that with the MongoDB 7.0, we improved like complex queries, basically. But here with the MongoDB 8.0, we also wanted to improve like simplified queries, basically the queries that only use a single field, single index as well. And how we did this? We are using now what we call the express stage. So what does this stage do? Essentially, it basically skips unnecessary steps so that these queries are also 17% improved in terms of latency. So now onto memory management. So in general, in order to improve raw performances, you need to take into consideration memory. And what happens, or how memory is used rather in MongoDB. So in MongoDB, you have the data, you have free space, but you also have fragments of free space. So these fragments of free space called memory fragmentation. And they are usually very small to be used. And these fragments are usually due to the fact that when you are running a query, you allocate and reallocate the space, which creates like more fragments in the memory, basically. And in order for you to like have better performances, we wanted also to improve the allocation, basically, the memory allocation. And in order to do this, what we did is that we used the latest version of Google TC-malloc, the Google allocator. Because like previously we were using the previous allocator, but by using the new allocator, basically now what we're doing is that we are leveraging the per CPU cache instead of the per thread cache. And by doing this, we were able to achieve basically 18% reduction in memory fragmentation, which means now we get better performances also during peak loads. One other important aspect, which is replication, which is one of the most important aspects in MongoDB. So we were also able to improve replication in MongoDB. So although, like when you are, for example, developing on your local machine, it's okay to have a single cluster, for example. But when we are talking about system performance, you need to take into consideration also that a replica set is a minimum of 3 nodes, which basically means you need to take into consideration the replication lag, you need to take into consideration the write concern, you need also to take into consideration the oplog. And the improvements that we've made in replication, basically, we were able to, instead of per operation, go and write that operation in the oplog. So now we're doing it in a grouped manner, basically. Whenever there is a write, we go and write the block of changes that has happened, which basically made the interaction between the primary and the secondaries, but also the write concern even faster. And basically, with this, like the default, even the default behavior, which is write concern majority, now it's faster, and it's 20% faster, to be exact. So usually, when you have basically spikes in workloads, whether it's like planned or unplanned. Planned, for example, I'm talking about, let's take retail into consideration. So when we're talking about, for example, Black Friday. So unplanned, let's say someone made a TikTok on a product, and suddenly you have a lot of people on your website trying to buy that product. So now you're getting spikes. These spikes can be either permanent or temporary. So there are two solutions. You can either scale the cluster, which is sometimes necessary to do, but you can also moderate your workload, basically. So what does this mean? So it means we made available like certain tools that lets you basically be proactive and solve that issue before it happens. So what we did is that we introduced what we call namespace insights. And with this dashboard, as you can see, you can pinpoint directly like which collection and which database are problematic, so that you can either like change the index or optimize the query that has been run. The second thing that we've introduced is query shape. So what is a query shape? A query shape is an identifier, as you can see, like query shape hash. And this query shape hash, you can basically use it for other operations. I'm gonna explain it in a minute. But the idea of this query shape first, to understand the shape of query. So what you are doing. So here, as you can see, we are doing a find on the sales.order collection, and we're trying to find the orders by the account ID. So let's imagine like this query basically is taking too long, or is causing problems in terms of performance. It's hogging basically resources. So now, by defining this query shape hash, what you can do is that you can take this query shape hash and reject the operation while waiting for the application team to optimize that operation. So basically, whenever you get a new query that has the same query shape hash, it's gonna get rejected. And once the application team like have solved basically the issue, then you can reset basically the rejection to false. And as you can see here, like you can reject all the incoming queries coming from this query hash by rejecting the settings to true. And you can, of course, prevent resource consumption, like unnecessary resource consumption. But most importantly is that there is no impact on your application, basically. Okay, the other thing, which is the default timeout. So here we also introduced a new feature, basically, where you can define the max time MS for a read operation. So let's say you want like all your read operations to not exceed 5 seconds. So you can define that, and basically if there is any query that exceeds that, it's gonna get rejected. So here, again, no changes to your application code. It's an admin command. You define the number of seconds after which you want basically the read to be aborted. And then when, again, the read operation has been optimized or indexes has been created, basically this operation will be run with no problems. The other important thing is that this is a server-side command. So if there are, for example, we're thinking about analytical query, a complex analytical query that might take more than 5 seconds, you can actually override this at the operation level. So And you can also do it directly through the Atlas UI by defining, as you can see here, the 5 milliseconds. And you can, of course, turn it off or change it whenever you want. The other important feature that was highly requested, actually, which is the persistent query settings. So here what you can do is that you can persist an index filter, and if there is, for example, a cluster restart, you won't lose that persistent setting. Because if you, for example, defined a persistent settings, whenever there was a restart of the cluster, you would lose that setting. So now, by defining this, you won't lose that. So here, as you can see, we're defining index filter. actually standardizing this. And last but not least, queryable encryption. So what is first queryable encryption? Queryable encryption is the ability to encrypt, for example, sensitive fields, even like when they leave the application, they get encrypted. What does this mean? Is that only the application can actually see the data decrypted. So when the data is stored in Atlas, when you open, for example, a document, you're going to see it in cipher text. So now we are restricting your circle of trust. And when we introduced this feature, we made it available, or we made it possible for equality matches. So let's say, for example, we want to retrieve all the records related to a specific patient using their social security number. So you were able to do that, and you are still able to do that, based on equality matches. But one other demand we had is range queries, and this is what we are making available now. So basically now, let's say I want to retrieve all the patients that are, for example, 30 years and older. So you can do that even, for example, the birth field is completely encrypted. You still can perform range queries on those. That's it for our 4 key foundational aspects. So basically, the commitment that we made this year is to improve resiliency, scalability, security, and performance. And if, of course, any of the features that you saw here today, you like them, I would suggest you put together an upgrade plan and you start basically moving from MongoDB 7.0 to 8.0.